Hi everyone. Today we're going to try to solve a problem called group anagrams. This is number 49 in Leetcode. I think this is an interesting problem because the solution in this one requires you to evolve the problem. And I want to show you techniques of how you can just solve the problem with a brute force way and then identify bottlenecks and then improve from those bottlenecks to an actual solution that makes sense. Okay, so we're gonna first of all read the question, understand an example, and then note any unique cases that they mentioned, and then solve the problem and show you how you evolve into the final solution. Okay, so stay tuned. All right, so let's read the question. Given an array of strings, group the anagrams together. So for those who don't know what anagrams are, effectively they are words that, regardless of how you scramble it, you can form a new word. That's an anagram. For example, the word eat, right, contains E, A, T. Now, if you scramble that into another way, it'll become T, E, A. So these are two unique words that use the same characters, right? So these are actually anagrams of one another, right? So let's look at the actual example here. In this question, you're given an array of words, right? And your goal is to group anagrams together. Simple enough, right? So in this case, you're given eat, tea, 10, 8, nat, bat. And to group things together, 8, eat, tea. Oh my God, this is like a tongue twister. These are all containing the same characters of A, T, E, right? Same case with nat and tan. They all contain the characters of N, A, T. And for bat, they all contain the characters of B, A, T, right? So that's what we're expected to return. So that's something that we should note. It's an array of arrays of grouped things, right? So the third thing we may want to do is start notifying like, okay, what kind of unique tips that they're giving us, right? So there's a note here. And remember, I keep iterating this, that's saying that if they mention a note, it's there for a reason and it's important, right? So it's important. So when it says like all the inputs will be in lowercase. Okay, that is very helpful, but why? I'll tell you how why later on, and it'll be more self-explanatory when we start coding. But that keep that in the back of your mind and see that, okay, even if I come up with a brute force solution and I don't use these notes, maybe the notes will help me improve my algorithm further later on, right? So these are some things you have to think about. So the second thing says that the order of your output does not matter. I think that is actually very helpful. So I don't have to report alphabetical order. I can report in any order, and that's cool. So that means that, it makes this problem a lot easier, right? Because now we don't have to order it or whatnot. So that's cool. So now we have to think about how can we solve this in the most brute force, dumbest way possible, right? So if we think about it a little bit, oh my God, I have a messy hair day. But if we think about it a little bit, what is the definition of anagram, right? So what I mentioned earlier, an anagram, if it's an anagram of one another, they all contain the same character, right? Or at least contain the same collection of characters, right? So effectively, if we can find a way to, as we iterate through each word, to identify that word contains the same characters as the next word, then we should bundle it together, right? So we can create some sort of dictionary or storage cache that perhaps the key would be that identifier to identify whether or not a particular word contains the same values, right? So what can we think about? How can we ensure eat and tea, when we compare both of these together, they are the same? Well, they're words, right? So we need to do something to those words, right? When we look at these words, what can we do to ensure eat and tea are the same? Well, one thing we could do, if you think about it in brute force way, we could actually just, as we iterate through each word, we can sort that particular word in alphabetical order, right? So in other words, EAT will become AET. The TEA will also become AET. And if after you sorted the word and they have the same value, then we could group these two words together in that dictionary or cache, right? So we could do this through the whole word, and then we start analyzing what our time complexity of this equation would be, right? Before we go into code. Remember, one of the notes is like before you code anything, you should always understand your algorithm. The coding part is easy, but the hardest part is coming up with the actual algorithm, okay? So that's a really big tip. And make sure when you talk to interviewers or whatnot, you communicate effectively in your thought process of this particular way to solve problems, right? So what can we do here? Okay, so what is the time complexity of this algorithm, right? So for one, we know that we need to iterate through everything in that array, right? So traditionally we call that n, right? So O of n, right? However, we're not done there because we need to iterate through each of these words and then do something to that word, right? So if you're gonna sort a word, that typically is an n log n, right? However, in our case here, n represents the total length of the array. So we can't really use that character, right? The algebra character. So what we can do is I could just use any arbitrary character. There's no written rule that you must use a character. So I'm going to use W to represent the length of that particular word, okay? So in this case, the time complexity to solve this problem would be O of n times W log W, right? Simple enough. So let's try solving this problem with that. So with that in mind, O of n log n W log W, right? Time complexity. Okay, cool. So that seems pretty easy enough, right? So when we look at the space complexity, what are we going to be doing here, right? We're going to be creating an object that contains keys, that would have arrays of those actual words, right? So in this case, it's going to basically be the n of W. All right, cool. All right, so we're going to go let cache. I'm going to create a cache that would basically be the object that stores my keys that could basically group words together, right? So that's cool. That's simple enough. And the next thing I need to do is make sure I'm going to iterate through each word. So let the string of strings, so this plural indicates the array of words, right? All right, cool. So what am I going to do with that, right? So from this, I'm going to make sure that I'm going to go and create a sorted key, right? The sorted key is, I'm going to take that string, I'm going to break it up into little pieces, which is going to be split, right? So break up to little pieces, sort it, and then I'm going to make sure I need to join it together, right? To create that key. Now, we're going to have to go and check if this key, in this case, for the first word, the key would become AET, right? So what do we need to do here? We're going to check if this key exists in this particular cache, right? So we're going to go, all right, does the cache at the sorted key, right? Does that exist? So you can use this statement. Does it exist? Or I will use if it does not exist, okay? If it does not exist in that in the here, so it's falsy, what do I do? I'm just gonna make it exist now. So sorted key will equal to the array of that rare word, right? So what if it does exist, right? If this key does exist, then, well, simply I just go cache and the sorted key and ensure that I push the string value in there, right? So we have this. Now we created basically a cache that has keys that would be like AET, and then it's going to contain words like 8, eat, T, etc., 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 right? So that's what this is going to contain, right? So although that's an object, right? That's not really what we're trying to send. Remember, it's asking for array of arrays. So what can we do? Well, we can actually return the object.values of the cache, right? This will return the arrays of effectively all the elements within that key. So let's do that. Cool. Let's clean it up a little bit. And let's see if it solves the problem. And bingo, it does solve the problem. Great, right? So when we look at this problem, we're like, okay, cool, I solved the problem. I'm done, I'm good. But hold on a minute, right? Remember, they gave us this tip. Things are in lowercase. I didn't really use that in this question. So why did they give it to us? Maybe there's a reason for that, right? So when we look at this, analyze this, like where is the top bottleneck in this whole equation, right? So the biggest bottleneck I can see from this whole equation is, or this algorithm, is this sorting function, right? Because the sorting function naturally would have the n log n time, right? Or in this case, w log w, right? So what can we do to create a unique key, right, in this object and leverage what we've already done already, right? So when we think about it, what can we do to make EAT equal to TEA, right? What can we do? So let's think about it for a second. What can we do maybe mathematically or algebraically that we can do to ensure, regardless of the position of things, we ensure that the final number would be the same? So if you think for a second for mathematically, we could probably leverage multiplication, right? We could always go like 2 times 4 times 6 is the same as 6 times 2 times 4 as an example, right? These are not the as an example. So if we know that multiplication can help us get a unique key or value, then effectively all we need to do is convert these characters into a number and then multiply that number together, right? So as long as we multiply it, and that number will give us a unique key. And then we can use that unique key to store our anagrams, right? However, we have to think about, okay, well, we can't just multiply every number because if you multiply every single number, then there is a possibility to have 2 different words but come up with the same key, right? So we have to think about what kind of attributes do we have that when you multiply it together, it's unique. So we think harder, we can think about, well, we can actually think about, why don't, instead of using just arbitrary numbers to apply to each character, why don't we use prime numbers, right? Because one of the primes is, the key definition of prime is like there's no 2 numbers that can form that one number or create that one number, right? So that's kind of very unique. So if you multiply prime numbers together, you're gonna get something unique, right? Great. So we'll create a prime number that represents each character. So all we need is just 26 of these characters, right? So, but how can we extract the actual value from like a character, right? So there is a function that would help you, and that is called char code at, right? In this case, it could be 0 or you can leave it as nothing. This will return you 97. Now, how do we get this like weird ass 97 number? Well, you could always look at the docs, the MDSs. That's what I did over here. It's effectively something to deal with UTC codes, right? 16 code. But you could always do trial and error to figure out, okay, well, that's 97. That's great. And if we look at V or something, if you look at B, that's probably going to mean 98. So how can we normalize this, right? Because remember what we said, I'm going to just create a maybe I'll create an array of prime numbers, right? I'm just gonna copy and paste these prime numbers because I don't wanna remember them. So I copy and paste, 26 prime numbers here. So how can we get a code from this? Well, if we minus this by 97, right, then the results would effectively, this will be 0, this will be 1, right, if we minus by 97. So by using this can generate an index that references these prime numbers, right? So what can we do here? Well, all we need to do is like maybe, okay, now I just add in my prime numbers in this equation in here, right? Instead of sorting it, I'm gonna actually do something else now. I'm gonna actually take each of those characters, convert it to a number, multiply it, and create an actual key, right? So instead of calling it sorted key, I'm just gonna say key, okay? I'm gonna create a unique key. Key. All right, cool. So I'm gonna go here and say, okay, I'm gonna reduce it such that I'm gonna take the total, the first character, right? And I'm gonna do something to it. So what am I gonna do? I'm gonna take the total, right, times the primes at the index of when I come look at my character dot char code at, right, minus 97, right? So what this is really gonna do is like for the character A, it's basically gonna take the position, it's gonna take number 2, right? This will be 2 times the total. And I'm gonna get an initial value, my total will be like starting at 1, so it'll be 2 for the letter A. And then you're gonna get the next character, which is E, and E, I'll just make it B for example. B will be position 1, and then you take 3, so 2 times 3 will be equal to 6. And then the third and final will probably make it like some other number here, and you're gonna get the same character, right? So that's all we need to do. By doing this, we actually reduce this time complexity to now O of N W, because all we're doing is like looking at each character, converting it into a number, and that's it. That's a unique key. Now let's see if we submit and this is a solution or not. Submit. Oh, okay. I think I messed up here something. Must be something that doesn't make sense. All right, so there's an error here saying keys. All right, let's troubleshoot. Okay, keys makes sense. It's defined here. Why is it giving me an error? Okay, let's look at it. It goes down here. Oh, silly me. I'm missing a semicolon. Wonderful world of JavaScript. Let's submit this, see if this works. Bingo! Solves the problem. All right, so this hopefully was a good example to show how you can evolve a solution to be a little bit more efficient, and to show you that you can start applying math, finding ways to analyze your question and identifying bottlenecks. That's the key takeaway from this particular problem. Okay, hope you like this video, and stay tuned for more. Subscribe and like. And for those who are not part of it already, I've actually started a Discord channel for people that are enthusiasts in solving these problems. Feel free to join it. I'm going to link the description below how to join. So feel free to join, and stay tuned for the next one. Peace.